Right. I want to give a very quick primer on how face recognition works, and I will go through this at a quite fast pace, so if you want to look at any of the slides a little bit longer, feel free to just pause the video. First things first, I aggregated some of the areas where you can find face recognition being used today in industry, in practice, but at the same time, this is being used in many, many more areas, and new ways to use face recognition are actively being explored, and it's slowly proliferating our society. Next, I want to introduce some terminology to help us differentiate the different stages or steps that are involved in face recognition. The first thing is on the right-hand side, face detection, which is the process of, given an image, find areas in that image that show faces. And next we have face validation, which essentially is given two pictures of faces. Face validation tries to answer the question, are those two pictures from the same person, or are those two pictures showing different people? And then finally we have face recognition, which is given a new picture of an unknown person and a database of example pictures of people that we know. Can we figure out if this unknown picture belongs to any of the people that we know using the example pictures that we have of that person, of those different people? Sorry. Right. How do we stitch that together to make a general face recognition pipeline? Well, we first start by capturing an image, then we feed that into our face detection algorithm, which gives us the regions that contain faces. We then crop the image to only contain the face, and we discard all the other information. And then we take this face and we feed it into what's called an embedding, a nonlinear embedding to be precise. And what this embedding does is it's essentially like a identity preserving hashing function. So it takes a picture of a face and it spits out a point in something we call the latent space. And this latent space has the very nice property that if I have multiple pictures of the same person, these pictures will all be projected onto points that are very close together. Whereas if I have pictures of different people, they will be projected onto points that are quite far apart. And with this embedding, I can then very easily do face validation. I simply take my two images in question, feed them through my embedding, figure out which points they occupy in latent space, and then I measure the distance between those 2 points. And if the distance is large, they're different people. If the distance is close, they're the same person. And then once I can do that, I can very easily do face recognition as well. I simply take my database of all the pictures of people that I know about and do face validation with the new picture and every single picture in my database. And if I happen to find a match, then I know that, or if I happen to find a picture in my database that is close to the picture that I'm given, then I know that the picture that I'm given shows that particular person from my database. Now, I've marked the embedding step as the crux of the algorithm because this is sort of where all the magic happens. So I want to very briefly peek under the hood of this embedding and explain a bit how that one works. First of all, a very quick recap. An embedding is just a function that maps a high-dimensional space onto a lower-dimensional space. An example for an embedding that you may have come across before is a PCA, or principal component analysis. In fact, a PCA has been used to perform face recognition way back in the 1980s, and that algorithm is called eigenfaces. Nowadays we use something slightly more sophisticated, namely a deep neural network, because there we get much more parameters that we can fine-tune in order to control how this embedding is being performed. And the way we fine-tune these parameters and we figure out what is a good configuration for our network is we take example pictures of the same face, map it through our algorithm, and see where these points land in latent space. And then we modify the parameters of our model so that the next time we do this mapping, these pictures of similar faces will end up a little closer together in latent space. And we do the same for pictures of different faces, and then this time we make sure that the next time we do this, those pictures will end up a little further apart in latent space. And then we just iterate this process over and over again until we get sort of little clusters that are forming that are just containing one single person. And once I have these clusters, once I have a network that forms these clusters, I'm done with my training, because what I can do now is I can take my database for face recognition and I can map all the pictures in my database onto this latent space and figure out which regions they actually occupy. And now if I take a new face that I haven't seen before and map that through the model, All I need to do is to check whether or not this new picture from the unknown person falls into any of the regions that correspond to people that I know. And if it does, then this picture shows a person that I know and I've correctly identified the face. Thank you for your attention.